All right, so today we're gonna make a website in Bash. Now hold on, because I know what you might be thinking. You might be thinking, Dave, wait, hold on. Didn't you already make your website with Bash? And here's the thing. Yes, it's true that you can access my website through the web browser, and you can also curl it. And you can access my website in your terminal. That's awesome. So you might think, oh, I can access it with Bash. Well, you can access it in your terminal. What you're seeing is text and, ASCII art and ANSI escape sequences to do the coloring, but that's not actually Bash. Yes, I did use Bash scripts to generate it, but I run that statically, upload that to my server, and then my server is just transferring these like bytes, and then your terminal's rendering them. So I don't think that technically counts. Now you might also be thinking, okay, so we're just going to use Bash to what? Output HTML to a file and then put that on a server? No. We are going to take something like this. If you've ever done web development, you know how you can embed JavaScript directly in your HTML. We're going to change that, and we're going to do this. We are going to put Bash directly in your HTML, and at the end of this video, we are going to have this working. Hopefully, we're going to see if we can do it. So yeah, we're going to go ahead and make Bash work in your web browser. All right, so as you can tell from how white my face looks now, I'm about to hit you with that light mode jump scare. Get ready, 3, 2, 1, light mode. There we go. So we're on the website for Bash right here. As you can see, GNU Bash. Let's go ahead and scroll down, and let's go ahead and download it. So we've done this before in previous videos. We can pull up an HTTPS mirror here, and we're going to want the latest version of Bash. At the time of this recording, it is Bash 5.3. So let's go ahead, copy the link here, and then we can go over to our terminal and download it. So we got a fresh directory for us to work out of here. I went ahead and made a directory called Bash Web. As you can see, there's nothing in it. We are running on my Mac currently, and we are running on Bash version 5.3 ourselves, and we are also going to be compiling this latest version of Bash. So let's go ahead and grab that source code. So we can wget this. This will pull it. There we go. So now we have the tar.gz file. That's great. If we were to do a tar xf on it, you will see that. Here we go. We have the Bash 5.3 source code. All right, so let's pause here real quick. What's our plan of attack? Here's what I want to do. We're going to take the Bash source code and we're going to compile it. We're going to compile it specifically for the web. To do that, we are going to use wasm or WebAssembly. And to do that, we are going to use something called Emscripten. I've talked about it before in this channel. I haven't dived too much into it, but it's a really cool way of compiling like C programs. I think maybe some other languages, but I've only used it for C. We can compile things directly for the web by using WebAssembly. So we're going to have Bash, the actual Bash interpreter itself, compiled for the web. Our browser will run Bash, and it will hopefully be able to execute Bash code that is in our HTML files. So yeah, let's take a look at this. So we got the source code pulled down here. Let's pop it open real quick. And if you've never seen this before, it might be a little bit scary. You're like, oh man, there's a bunch of C files here. Well, yeah, this will be Bash. This will compile Bash. This will make the Bash shell for us. So let me show you that. If you've never done this before, it's actually really simple to compile software like this. There are two things you need. You need to configure. This will run and figure out a whole bunch of stuff about your machine, what you have in this machine, what's supported at build time, blah, 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 blah. You run the configure script, and this will do a whole bunch of feature detection. As you can see, it's going through right now and detecting a whole bunch of stuff about this machine that I'm running it on. So I'm running it on my Mac. It's detecting a whole bunch of things, like it knows that we're building on a Mac. It knows that we're compiling for a Mac. So it's figuring a whole bunch of stuff out. This could take a while. I'll let this run. Cool. So now that's done. And as you can see, a bunch of stuff here. Look, it made the make file for us. It made a whole bunch of stuff for us. So now there's only one command left to run. You can run make. Make also optionally takes a -J flag where I can have it do multiple jobs at once. I'm not going to bother doing that because I can just cut the video. And this doesn't take too long to run anyways. But this is going through and actually compiling all of it now, all the C code, all that stuff. So at the end of this, we will have a Bash interpreter compiled for our machine, not for the web, for our machine. Getting it to work on the web is going to take a little bit more work. That's some foreshadowing. Cool. And there we go. That finished. So what do we have here? We have a whole bunch of stuff, but take a look at this. There you go. Bash. In fact, I'm going to throw my glasses on because I can't really read it that well. Bash. There we go. So how can we check that it worked? We can do bash like this, and we can do, let's say, -- version, and there we go. We have a Bash 5.3.0. Remember, my current running shell is what, 5.3.3? Yes, this is a different running Bash right there. So I have this, it works. I could do something like echo hi, and that runs within the context of that shell. I could echo Bash version, note the single quotes. This is being passed to the version of Bash that we're forking. A little bit confusing, but you can see that we were successfully able to compile it on our machine. That's great. Let's figure out how to compile it for the web, okay? So the first thing we want to do here is not mess around with what we've already done because we've modified that source code. We've changed a bunch of things. We ran the configure script for our own machine. We want to start with a blank slate. So let's go ahead and get rid of that source directory. We still have the tarball, but we got rid of the source directory so we can untar it again. And now we have that blank slate. And that means we don't have the compiled basher anymore. We don't have anything that's been configured there. We have a completely clean, pristine 5.3 release of bash source code checked out. Pretty cool. So to get this compiled, we are going to need Emscripten. Now, Emscripten is awesome. It's a whole suite of tools, but namely it comes with things to handle configure and make style builds, which is super nice. So here's the website for it right now. The beautiful thing is that we actually don't need to download it from the website. I'm on my Mac. We can just download it from Homebrew. So if you go over here, you know, your operating system may vary. You might have like apt install or whatever. I have brew install Emscripten like that. And I'm going to go ahead and install this. And ooh, auto updating Homebrew. All right, this is going to take a long time. So I might just go check out for a bit and then I'll come back when this is done. This could be a while. There we go. Now it's installed and we can check for it by running em and then hit tab a bunch of times. And there's going to be a bunch of stuff here. But look, we have em make and em configure. This is what we are going to use because em configure allows you to wrap a configure script and em make allows you to wrap a make program basically. So for instance, if I were to run em configure on its own, it will give you a usage message. Look, it wants you to run em configure and then give it the configure script, which is super nice. If you run em make, look, it wants you to run make. So it basically just wraps these two commands. Remember how we use configure and make to build bash? We're going to use them to compile them for wasm. Now, to make things cleaner though, because I don't really want to mess with the source code that much until we, actually have to, we're going to make a new directory. Let's make a dir called build, and we will do all of our build steps in here. That way, when we have to iterate, we can knock out this directory without having to re-untar the bash source code. So let's go into build. And one of the beautiful things here is we can use em configure, and we can give it the configure script, but we can give it to it like this. So even though this script is in a different directory, it will run out of our build directory. So let's run this and just see what happens. So if I'm compiling anything for wasm using Emscripten, this is pretty much what I'm starting with. Like if it's a configure make type of compilation, I'm gonna try em configure, I'm gonna try em make, and we're gonna hope that it works. I'm gonna give you a little spoiler here. It's not gonna work, but we're gonna talk about what breaks, and that's gonna be a lot of the fun of the video here. Cool, so there we go. This actually succeeded, so that is awesome. The configure script actually run. Now remember, we didn't run this in the bash source code directory. We are in this build directory, but look, it generated a whole bunch of files for us, which is pretty cool. So we have this make file, so we should just be able to now make the source, right? So em make, and then we can run make, and this will go through and do everything we need. So let's try this and see what happens. And we got an error. So let's take a look at the error here. So look at this. There's a whole bunch of warnings generated, blah, 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 blah. Bash built-ins alias.def, no such file directory. Rename this, no such file directory. What is going on here? All right, so if we run em make again, we can see that here's the error message we're getting. Look at this. This file, no such file directory. Now, of course, that makes sense, right? Because in our current directory, if we look at this, if we try to go up one level twice, we're going to be outside of it. I can do a little stat on that, and you can see that we get no such file directory. That makes sense, but is that the whole picture? Because it seems like a little bit confusing. Let me go ahead and show you a cool way I can debug this. This works for normal make files. Em make just wraps it. We can do all caps shell equals, and we can give it our own shell. Now by default it would use the POSIX shell, but we can give the POSIX shell the -x argument, and we can see exactly what it's running. So it'll put a plus sign in front of it when it's running a command. So you can see it's running cd into built-in, so it's going into the built-ins directory. And then when you're in the built-ins directory, suddenly this ... makes a lot of sense. But we're still getting an issue. It's running this command, make built-ins, inside the built-ins directory. A little bit confusing, but if we cd into built-ins, there is a command here named make built-ins. It's running this command. It's attempting to run this on our system. Does this work on our system? Well, here's the thing. Look at this. It's a node script. This is JavaScript. If I vim it, look, this is JavaScript. Because it built it for wasm, we're gonna have a hard time running on our own machine. We don't want this to be built for wasm. We want this part to actually be built. Like this is a C program. We're gonna want this to run on our actual machine. So we need some programs compiled for our build machine and some programs compiled for our inevitable machine where the code ends up running out of, which is the host machine. So we're doing a compilation on one machine, but we're hosting it on a different machine. We're cross-compiling technically. So we're gonna have to deal with that reality. And that's where things get a little bit confusing, but hopefully you'll stick with me here. So here's the thing. When you run that configure script, let me remember where I have that, em configure, there we go. When I run this configure script, I can give it -h for a help message, and here's the help message. If you've ever looked at a configure's help message before, this is gonna look totally normal to you. If you've never looked at /configure and all the options, you're gonna be like, wow, that's a lot. Yes, there's a lot here. Luckily, we don't have to do it, but this allows you to configure bash when you're compiling it. So I can enable glob ASCII ranges, enable history, enable job control. Any one that I can enable, I can also disable. I can compile bash without process substitution. I can compile bash without readline. You have all these options when you're compiling, which is super cool, super awesome. But the thing we care about here is look at this, the system types. Notice how there is a -- build and a -- host. So on this machine, by default, it's assuming that the host and the build machine are the same, meaning I'm going to compile it on the same machine that I'm going to run it on. So when I used emconfigure, it compiled it for wasm. We tried to run make built-ins. It didn't really work that way. So we need to tell this script that, hey, we're going to build on the Mac, but we're going to run in wasm. So this is where we get into our first configure flag, so we have to start passing in. And the nice thing is, it does a really good job of guessing. Bash has a little built-in script that we can leverage here, which is super useful. So in the Bash source code, under their support directory, there are a whole bunch of scripts here and things we can use. There's a script called config.guess. Why it's not executable, I do not know. But there's a script here. I can show you what's inside it. If you vim that script, you can see that it is a shell script, which is super nice. So I can run this shell script and it will give me a guess as to what machine I'm running on. So let me show you. I could run it with shell. I could run it with bash. Let me just run it, bash this script, and it will say AR16, Apple, Darwin, whatever. So this is a nice machine triple for me. It knows what kind of machine I'm on. I think you can get this like machine type. This is an example of it. Yeah. So my current shell thinks I'm on this, and this is able to get it like this. Wow, the Darwin version is different. Interesting. Huh. Either way, this is what it guesses my machine is. So we're going to use this when we run that configure script. We also need to target wasm. So the way to do that is by giving it the wasm triple. Now, if you've compiled for wasm before, you've probably seen something similar like this. Like I've done this from Rust and I've seen this. If you've never done it, you're going to be like, wow, this is super weird, but bear with me. So we have our build machine. This is the machine we are building on. There's a couple things we could do. We could actually just literally call this script like this, and that is totally valid. So we're going to go ahead and do that. That way, this is, if you're watching at home and you're following along, you could run this and this will totally work. But then we also need our host machine. And for this, we're going to need the wasm host triple that we can use here. That is wasm 32-bit dash unknown, because it doesn't really matter what's going on for the manufacturer here. And then the version number here, we can also put unknown. We could also put Emscripten. Again, this doesn't really make that big of a difference. The most important thing is wasm 32. So we're building on our current machine, and we are building it for wasm 32. So this completely changes how some things are done. Now, here's the thing. I like to just kind of clean up everything here because I don't know if it's going to use some sort of cache values and stuff. So let's go ahead. We are in our build directory. We can just wipe this whole directory out. So go ahead and run rm-rf star pause right there. Be careful with this command. Guys, be careful with this command. I know this will only delete what's in my current directory. Please be careful with this command, okay? I'm an expert here, so I can go ahead and run that. We can verify that, yes, the directory is empty now. So let's go ahead and rerun this with the new -- build and -- host. And let's see what happens here. Cool. So same deal. It was able to configure just fine. Let's go ahead and run emake, make, or make, and see what happens this time. We get an error again. Okay, cool. So what's happening with this error? Well, if we scroll up, we can see we get some warnings. Not a big deal. I don't care about warnings right now. Error. Assigning to sigset T. Okay, we have a struct of sigset T from incompatible type. So it looks like there's some differences in these signatures for modifying signals here. All right, so basically our configure script, which is detecting features, is failing to detect that Emscripten is giving us some sort of POSIX signal emulation, or at least some small subset of it. So we can do a couple things about this. In our current directory, we have our config.h, and if we take a look at this, this was generated from config.h.in, so configure makes this for us. It is a configuration file for bash, so this gets used when it comes time to actually compile it. There's a whole bunch of stuff in here, all sorts of things, like do we want history? So remember how these were options to configure? It wrote out this H file based on that configure script, so all of our stuff is here. So if we were to search this for, let's say, signal, we can see, look at this, have BSD signals, have POSIX signals, blah, blah, blah. We want this to be yes. We want to say, hey, we actually do have POSIX signals, even though configure failed to notice it. So what we can do here is we could change this to, there's a couple things we can do. We could change this to define have POSIX signals to 1, and then we basically manually say that, hey, yes, we have POSIX signals. That's great. I'm going to do a better way or a cleaner way or a way that we can kind of iterate on this, because two things. One, if we modify this config.h and we reconfigure, those changes will get destroyed. The other thing is I'm cutting it out of the video, but running ./configure takes a long time. There is a way to speed it up. So we're going to kill two birds with one stone with this. Let's start over. Okay, bear with me here. We're going to start over. We're going to, again, get rid of everything here. And we're going to rerun that configure script, but we're going to pass in the -h here because I want to get the help message because there's a lot of stuff in here. And in here, look at this. We have a config cache. So alias for cache file config.cache, blah, blah, blah. We can give it a cache file to use, which is pretty cool. So -- cache file equals file. So let's go ahead and pass this in. We're going to create a cache file. It will cache its answers there, so it only has to detect them once. So -- cache file equals, we're going to put this outside of the build directory, so we won't wipe it out. We will just call this cache.txt. So we don't have anything in there. This is an empty file. It does not exist. It's not even an empty file. It does not exist. We're going to run this, and it's going to run through that whole configure thing again, but it's going to write out that file, and we can modify that file and lie to configure, okay? So we're gonna do it this way. Like I said, I don't know what the best approach is here. Probably some sort of better feature detection with POSIX signals and Emscripten stuff. I don't feel like diving into that for this video. I just wanna get things working. This is a proof of concept. So yeah, I'll check back in when this is done. Cool, so the configure finished. Now remember, if we go look at this cache file, let's see what we got going on here. This is large. There's a lot of stuff in here. I'm going to go ahead and set no spell because we don't want spell checking because that's ridiculous. Is there anything else we can do? Set ft equals ini? Nah, I don't even know if there's like a nicer way to look at this. Maybe conf? Oh, that's a little bit nicer. Okay, we at least get some syntax highlighting. This file is a shell script that caches the results of configure tests run in the system so they can be shared between configure scripts and configure runs, blah, 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 blah. It is not useful in other systems. If it contains results you don't want to keep, you may remove it or edit it. So basically, this is our running config that we're going to be messing with for the duration of this video. So the cool thing is, now that we're here, we can go look at that signal stuff. So we can go look for signals that are all there. I don't know exactly where they're going to be. It's a little bit hard to read this. Look at this. Bash CV POSIX signals. Again, a little bit hard to read. I could highlight the whole line. Maybe that helps. So it detected that we don't have POSIX signals. Here's the thing. Yes, we do. And we want to use them in our WASM environment. So I could change just this no to no, or I could just overwrite the whole thing. I'm just going to overwrite the whole thing because then it's clear. It kind of signals our intent here. There are a couple other ones here. So you can see our signal vintage is V7. Absolutely not. We want POSIX. We want POSIX signals. And then there was another one, which was, I think the sigset T was the error we were getting. So let's see. Bash type sigset T is yes. Let's just verify. Yes, that should be the case. So now that we have POSIX signals, sigset T, and all that correct vintage setup, this should work how we expect. So again, we're going to blow everything out of this directory. I actually don't know if this is necessary or not, but let's just do it for a nice clean slate. And I can show you how fast this configure will run now that we're using that cache file that already exists. So if we run this, now it's just like way faster. I know I cut the video, but look, I didn't even cut the video here. It's just so much faster, so much nicer for me, okay? So now that we have this, let's go ahead and run the em make again and see if we can get any farther. Look, no errors yet. We're getting warnings, but no errors yet. Oh, wow. Is it actually going to compile? Do we have something working here? Let's see. Cool. So it failed to compile, but not a huge deal. I kind of expected that would happen. We are failing with GetRandom. So what's going on here? We have a static declaration of GetRandom. This is a function that's been declared. And we can see that, okay, look at this. It's coming from random.c in the bash source code. But look at this. We also have a previous declaration of it here in Emscripten. So it looks like Emscripten gives us a GetRandom function we can use. Bash also has its own version of GetRandom that is compiled in there. So we got to figure out how to make it so they don't clash with each other. So here we go. It's in the bash source code lib sh random. Let's go there real quick. So bash 5.3 lib sh vim random.c. So we can see functions for managing 16-bit and 32-bit random numbers. So let's go take a look for GetRandom, and you can see, okay, this is really interesting. So it looks like there's a have GetRandom flag that we can kind of check for. We emulate it below. So this function is defined when it looks like we don't have GetRandom. So that's interesting, right? It seems like we do have GetRandom in Emscripten, but Bash for some reason thinks we don't, so it defines it itself. That's a little problematic. So what we can do here is we can go back to our old directory, which is the build directory, and we can look at that config.h, or we could modify that configure script. Let's just double check here first. Have GetRandom. So it looks like it did not detect GetRandom. So that is not great because it looks like we have it with Emscripten, right? So let's go ahead and look at that cache file again. Let's search for GetRandom. Super ugly file. I apologize. Look, it has no here. So let's go ahead and change this to yes, because it looks like Emscripten gives us a version of GetRandom that's going to work. So let's change that to yes, and the same exact deal here. I'm just going to blow these all away. Again, I don't know if this is necessary every time, but it's simple enough because the script works so much faster now. I actually don't care. It's not taking a lot of time to do this. All right, let's go ahead and run em make again. And hopefully this will get farther because GetRandom should be there. It's already defined by Emscripten, so we shouldn't have an issue with it. It should be able to get past that. Maybe it'll compile successfully. Let's see. All right, so we got another error here. So let's take a look at this error. Look at this. Duplicate symbols, PC, UP, and BC. It looks like it's in readline and term cap. So we are defining something in Bash. It looks like lib readline, whatever this is, terminal.o. Okay, so we're defining something that looks like it's already defined. There's a couple things that's going on here. So readline is the library that allows me to do things like when I'm typing in my command here, like echo, hello, how are you? And I can jump back and forth and I can press up and down to go back through my history, control U to clear. That's called readline. We don't technically need readline for this, proof of concept. We could just disable readline, and configure gives us the option to do that. We could also fix the source code. We have two different options here. I'm going to opt to do the source code here, and I'll show you why in a second, but let's go ahead and take a look at this file. So in the bash 5.3 source code, we have lib, let's see what it is, readline, and there's terminal.o, so terminal.c. So here we go. And if we look, I think it was like BC was one of the variables. Here we go, take a look at this. So it's a little bit hard to read if you've never seen this kind of thing before, but we have a car PC, a character pointer to BC, and a character pointer to UP. This extern keyword is the problem, or actually it will fix the problem here. Extern in C. So basically what's happening is either this line is creating a new character thing on its own, or it's looking like this. So either it looks like this, or it looks like this without the extern. We're getting one or the other. This extern is turned on only if it's EMX or it needs extern PC. That's the only way it's turned on. Extern in C basically says, hey, this thing exists, but it's somewhere else. Like I promise you it's somewhere else. When we go to run this program, it's going to be there. If you don't have extern, you're saying, hey, I'm defining this here. This actually lives here. It's not external to this program. It's being defined here. So we want this to be extern, and it's not being set as extern. So a really simple fix for this is we can just add our own little thing to this. We could check if defined Emscripten and with the two underscores like this. Now, as you can see like underscore GNU herd, underscore Linux, underscore EMX. This is kind of classic. Like the platforms and stuff will expose these variables. They'll define these variables so you can check them at compile time, which is super nice. Emscripten gives you this. So if Emscripten is set, then we will toss the extern keyword in front of it, which is super nice because we just modified source code. We can just run em make again, and let's see if we can get past that. Well, we got past it. We have more errors, but we got past it. So that's the cool thing. We didn't have to turn off readline. We're not going to use it, but we didn't have to turn it off. That feature works. It was just one small little fix to make it so we're not duplicating symbols there. Here's our next problem, malloc. So Bash includes its own version of malloc, basically. There's more to the story than that, but it has its own like GNU malloc interpretation, and wasm gives us malloc. We don't need to use the Bash implementation, but luckily Bash gives us the option to turn it off. So remember how we fixed readline with code? We're going to fix this with the configure script, and I'll show you what I mean by that. Because let's go ahead and rerun the configure with -h to get the help message. And again, there's a whole bunch of stuff here. Let's type in malloc. Look at this. With bash malloc, use the bash version of malloc. With GNU malloc, synonym for with bash malloc. Okay, so whenever there's a with, there's a without. So we can configure it without bash malloc, which is super cool. So we could rerun this with the -- with bash malloc, change that to without bash malloc. Now I'm going to go ahead and stop that. I'm going to delete everything that's here, and we're going to rerun the configure now without bash malloc. We're basically saying, hey, Bash, don't do your own fancy interpretation of memory allocation. Just lean on whatever wasm gives us. Now that we have that, em make, and let's see what happens here. Cool. So we got another error message, but this is good because it's not the same error message. Error messages are actually good when you're iteratively solving a process like that. So if you're watching this video, you're like, Dave, you get a lot of errors. Don't worry. That's totally fine. And if you're watching this video and you like what you see, go ahead and hit the subscribe button, all right? I got 92,000 subscribers at the time of this video. I want to hit 100,000 subscribers. I'm on track to hit it this year. Why not make that sooner rather than later? So go ahead and hit subscribe. That's it. So what's going on here? Take a look at this. Undefined symbol GetRandom. It looks like the GetRandom thing is biting us again. So what's actually happening here is at compile time, we told it, hey, we already have GetRandom, and we do. wasm gave us GetRandom. At linking time, that's when, when you compile something, you're writing the checks. When you're linking, you're caching the checks. We failed. We basically, like, when it came time to link it, we were like, oh, we actually don't have an implementation of GetRandom that we can use. So we're going to have to re-put in that bash version of GetRandom. So let's go ahead and make that work. This will be our fallback GetRandom in case something just doesn't work the way we expect it, but let's go ahead and pull that source code back up. I don't remember what it is off the top of my head. libshrandom. Oh, I'm awesome. Look at that. Okay, so here's what we're going to do here. If not defined have GetRandom, then we go through and we define it down here. That's all it is. It's very, very simple. If it's not defined, like if we don't have GetRandom, let's go ahead and define it. I'm going to negate this. Let's say if defined have GetRandom, then let's put a comma here. We have GetRandom, else we don't have GetRandom. Okay, so this is exactly the same. We just have an empty block up here. If we have GetRandom, we should do something. We should keep track of it. Sounds weird. Hear me out. If we have GetRandom, then we should define bash GetRandom. This is a new symbol that I'm creating. I could have named this anything to GetRandom. It's very confusing. I'm defining this symbol to the one that we have, because remember, it's defined that we have it. So this is the one that we have. This is the one that's provided by whatever system we're running on. If we don't have it, then we define our own. You can see we define our own right here. Let's go down here. Let's rename this so we don't clash any names. We'll call this bash underscore GetRandom. This is a brand new name, so we're not clashing anything. So let's go ahead at the bottom of this function and let's put this in here. Define bash underscore GetRandom to bash underscore GetRandom. This might be confusing. Let me walk you through what I did right here. If defined have GetRandom, if the system provides a version of the function that's good for us, then we will use the version of the function that's good for us, and we will save it as this symbol. This is just a random name. It could have been named foo. That's what we have now in the source code. Now, if we don't have it, if we're in the situation where we have to emulate it imperfectly, then we will define a new function called bash underscore GetRandom. Doesn't matter what we name this function, because we're going to use the same name here. So this is the same name as the one that the system provided. That way, anytime GetRandom is called, if we go to the bottom of the source code, you can see that it's called here. We just swap this out with that new symbol we just created, bash GetRandom. This will use the function that's available to us. That's what's effectively happening here. So we can save this. We can go back here. We can run make, and now we'll have a version of GetRandom that works. We're gonna have to reconfigure. I just thought about this. We have to go back to the cache file, and we have to find the GetRandom thing that we have set to yes here. We can change this to no, and which is back to how it was originally. And let's just go ahead, trash this. And I always make sure I'm in the right directory before I run that, guys. Be really careful when you run that command. I probably shouldn't even be teaching you guys to run rm-rf star. Be careful when you use your computer, okay? So reconfiguring, rerun make, and we will see how far it gets this time, now that we have a working version of GetRandom. It works. It works. Or more accurately, it compiled. We have a compiled version of Bash for wasm without the custom allocator, with some fixes to get readline working, but we have a version of Bash that should work. So what do we have? We have Bash here and we have bash.wasm. Here's the thing about this Bash command here. Let's go ahead and take a look at that. It is a node script. It's JavaScript, okay? And this is important. We're going to use this later, but remember, this is JavaScript, so we can pull this into our browser, and then we have bash.wasm. With those two files, we can do something. So let's do something, okay? This build directory is great. We've been wiping it out a bunch, so let's get out of that build directory because I don't want to be in something that we might accidentally wipe out. We're in the root directory where we've done all our work. Let's go ahead and make a new dir here called web. Now we can actually start hosting some files here. Let's copy over those files that we had. So let's cp build bash.wasm into our current directory, and let's cp build bash, remember this is the JavaScript file, to bash.js. So I gave it the JS extension just so we know exactly what it is. We have these two files now. We can do this and we can see that. Here we go. let's go ahead and let's make index.html. So we're going to make a super simple HTML file here. If you've never made an HTML file, buckle up. They're super boring. I have this just committed to memory because I've done it so many times. Are you supposed to capitalize wasm like that? I actually don't know if that's how people do it. Actually, looking at this, it almost looks like you're not supposed to. I wonder if you're not supposed to. I don't know. I'm probably going to cut this out of the video anyways, right? There we go. The only thing we need to do now is pull in that script. So we have source equals bash.js. Now, the nice thing about this is we don't need to do anything with the bash wasm file because the JS file that Emscripten produced for us will automatically include that. So if you search this source code for bash.wasm, look at this. It finds that file for us, which is super nice. So all we have to do is run a whole bunch of JavaScript that Emscripten gave for us. So we're going to go ahead and host this. We can use Python. There's all sorts of web browsers or web servers you can use. I'm just going to use the http.server here. And now it's running on port 8000 on my local machine. It's also, I think, available to anyone on my network, but luckily it's just me. Let's go ahead, pop open the browser, and let's see what we got here. All right, so here we go. It's prompting us for input. What kind of input? I don't know. Let's try echo hello. How are you today? And hit enter. Okay, well, it's prompting us for input again. Let's go ahead and pull up the console. Look at this. Do you see it? This program 5.3, echo, hello, how are you today? Hello, how are you today? Exit, and then it's gone. So technically speaking, using the worst interface possible, we have compiled Bash for the web browser. Go us. This is huge. There's still a lot of work to do, but this is huge. Let's refresh the page. Go back into that loop again. So we'll put this up here, and we'll do like echo hi. Actually, let's do this. For I in 1.3, I have to write bash perfectly. Do echo I is $I. Done. Okay, let's pull up the console. I is 1, I is 2, I is 3. Look at that! We got Bash working in the JavaScript console. This is so dumb, dude. This is so funny. So the problem here, it's not really a problem. I mean, this works just fine. The thing here is that it is waiting for input from the user because Bash ran with no arguments. If we were to give it, let's say, a script, for instance, like bash comma or bash space the name of the program, then it would just run that and it wouldn't be waiting for input. So we can go ahead and do that next. We just have to change a couple things. We're gonna have to use a little bit of Emscripten here to create the module object. There's a whole bunch of stuff here, like it can handle standard out, standard error. There's a whole bunch of stuff. I can specify the memory here. I can do all sorts of interesting things. On runtime initialize, I can have a JavaScript callback when things are ready to go. I can say no exit from runtime, no initial run. I can stop it from running initially. I can call it. There's a whole bunch of stuff we can do here. I'll show you what this looks like. Let's take that index.html and let's CP it over to, I don't know, we can call this simple.html. Terrible names, but let's roll with it right now. Simple.html. Let's do a little bit of work here. So before we load in that file, we're going to define our own module. So var module equals this, and then we can give it our own options. So some of the options it took were like a function for print. So we could say print if we're given this text here, then we can console.log the actual text. I don't technically need to do this. This is the default behavior, so I'm just overwriting it to set the default here, but we'll change this in the future. So just know if I didn't override this, it would be going to the console anyways. We have print error, and we can do console.error on it or console.log. Doesn't really matter. It's sort of the same thing. So we have our print text and our print error. There is some other stuff we can do here. We had no initial run. We could set this to true, and then it won't run initially. It's going to wait for us, or the JavaScript here, to run the bash binary, which is pretty cool. And the last thing here, which is really cool, was on runtime initialized, which again also is a function, so we can do this. It takes no arguments, but the beautiful thing here is if set, the function is called when the runtime is fully initialized. That is when compiled code is safe to run, which is after any asynchronous startup operations have completed. So this is really, really cool because now we can actually, this is where we would run bash with some input or something like that. So basically our goals here should be to write user input into a script file execute that file. That's what we need to do here. That's what we have to figure out how to do here. So in order to put that into a script file, we're gonna need some things. So I'll show you what I mean by that, because that was definitely very vague what I just said. Let's go ahead and pull the web browser back up. Let's go ahead and get the web server started, pull the web browser back up, go here. All right, we got the simple HTML page here. Remember, it's not running, so nothing actually shows up. We can go to the console and kind of inspect what's going on. Here's the thing, we have that module variable. I don't know how readable this is, I apologize, it might be a little bit small. The module variable has a whole bunch of stuff here, but what it doesn't have is .fs. We don't have access to the file system, and we don't have a call main function, which will allow us to start it. It was started before for us automatically. We need access to these two things. So here's the thing, you can expose these things, but we're gonna have to recompile it. It's not a big deal, but there are some linker flags we can specify when compiling. There's a whole bunch of stuff we can do here, which is super cool. But some of the things we're gonna care about right now are, let me find it, file system. So what Emscripten does is it tries to figure out if you need a file system based on if it can detect it or not, like if it looks like you're trying to do things with the file system. It doesn't look like we're doing anything with the file system, but we're gonna want to, so we're gonna set force file system to true. This will force a file system emulation we'll be able to access with module.fs. Beyond that, we also need call main. So to do that, we have, what is it? It should be runtime functions. Exported runtime methods, runtime elements that are exported to module by default. So you can export certain things. So we're going to export FS. We're also going to export call main. That way we can access these two things. So I'll show you how to do that. It's a little bit gnarly, but yeah, I'll show you. So in order to do that, let's go back in the build directory, and where we called emake, we're going to change it ever so slightly. We're going to add some LD flags. So there's a flags going to the linker, LD flags equal, and then the whole thing will be in a string. So we can pass in the first one, which was force file system equals 1, so we're going to force the file system. And the second one was exported runtime methods equals fs comma call main. So these are the two methods that we want to export. So let's go ahead and rerun this. Oh, it's not going to do anything by default. Let's go ahead and do a make clean, and then we will rerun this. So this will just do the recompilation step. It'll take a little bit to run, but not a huge deal. There we go, it's recompiled. So let's back out of here. Let's go into the web directory. Oh, I see it in my home directory. Yeah, I'm smart, I'm good at computers. Let's go into the web directory. There we go. And now we copied over the bash.js and bash.wasm files here. So that's not great because we've modified those. So let's go ahead and get rid of those two things here, and let's symlink them. That way they'll always be up to date with what's in our build directory. So build bash.wasm, we'll just symlink that. So now we'll have bash.wasm here. Let's also symlink bash on its own, but we need to give that a custom name. So bash.js, and there we go. Now we have two things here, but they are symlinks, so they'll automatically be pointing to whatever's in the build directory. Let's go back over to the web browser and see what we got going on with our simple thing. Refresh this. Didn't start the web server. All right, I'm getting annoyed of having to keep doing this server over and over again. So here's what we're going to do. We're going to start the server. We're going to throw out all of the output, and we're going to put it in the background. So there we go. The web server's running. It's in the background. It'll run as long as this terminal's up. So now if we go back to the web browser, it should just be there, and we shouldn't get any warnings. That's great. Ugly white screen, but that's okay. Let's look at the console and see what we have here. Remember we have that all caps module variable? Well, if we look now, we have, look at that. We have FS, we have all sorts of FS things like chdir, chmod, chown. We can create files, that's really great. We also have call main, so we can actually call the main function manually. Can't find variable txt, hey, that's not great. So something's wrong here, but we will figure this out as we go forward. So the FS module is here. I'm not gonna go through all of it, but this is everything you can do with the .fs thing that's part of module. So make dev, register device, a whole bunch of stuff. We're going to use a couple of them. We're going to use make dir to like make a directory to work out of. Actually, we don't even need that. We're going to use write file. That's pretty much the only thing we're going to want here. So write file, this isn't even the documentation for it. You give it the name of the file, the contents of the file, and that's it. So we're going to write a script into this file, and that's pretty much it. That's all we're going to do. Then we're going to call main, and call main is going to take a couple arguments, but we'll deal with that. So let's go here. Let's look at our simple one, and let's see what we got going on here. Run bash with some input. Write user input into a script file. So module.fs.write file, and this takes the name of the file and then what we want to give it. So we could just call it script.sh. We don't technically need the .sh, extension because it's technically a bash script. So why not just call it /script? There we go. And then the contents of the script file will go here. So the contents of this file should be what? Something simple like echo hello world. There we go. There's a really basic script. We could put a new line in there. It doesn't really matter. Let's go ahead and write that file out. Now we need to execute that file. To do that, we need that call main thing. So call main, there we go. Now this takes the arguments you give bash. So it's gonna call bash, but we need to give it an argument, and we can do all sorts of things here. We could do like, -x or -u or however you wanna call it. We are just gonna give it the name of the file. So the name of the file above was script, we'll just give it that. There we go. We're gonna call bash with the name of the file, and that is it. That is all that's gonna happen. Super duper simple. Oh, I just realized looking at that error message we were getting was because I didn't define, I used txt and text up here. Oh man, that error message was my fault. I'm stupid. How funny is that? Let's go ahead and clean that up because that would have caused errors later on. Let's not deal with that. Let's go back to the browser and see what's happening. I gotta organize these better. Let's put this all the way at the beginning. Let's close out of some of these things. There we go. Let's rerun this. Let's pull up the console and take a look at this. Hello world shows up right there. We also get unsupported syscall, unsupported syscall, unsupported syscall, and we also get a program exited with this and all this, blah, blah, blah. Who cares about that? That's standard error. Does anyone care about standard error? Let's look at standard out, okay? Let's focus on the positives, and that's standard out, and it says hello world. That is amazing. That is incredible. So that is awesome. We are running bash inside the web browser. Insane and awesome. Yeah, this is great. Let's clean things up. Let's make it a little bit better. Because right now, the source just kind of lives in a JavaScript variable. That's not great. Let's give the user some sort of like text area. Let's do that as our next level of iteration, right? So let's cp simple over to text area.html. Now we can modify this to sort of have a text input field where we could actually put like a whole script if we wanted to. So let's actually make a body here. Real quick, I'm gonna do something. I'm gonna do something because it's been really annoying me. Let's go ahead and make the body background color just a little bit not black. And let's go ahead and make the text color just a little bit not white because man, I really hate light mode. It is just too bright. So there we go. Now we're just changing the color just ever so slightly. Let's go ahead and add some elements here. So we want a text area, input, so ID is input. We could put a script here later. We want a button, so let's say button ID equals run, so we'll have a run button for this. We should probably give it some text, huh? There we go. And then we want a place where the output goes. So let's go ahead and be bad about this and just use our BR tags because I learned how to write HTML in the 90s. Let's make a place to actually dump the output of the code. So pre-code ID equals output code pre. There we go. So let's do this. There we go. So now when we get down here, we need to actually do something meaningful. Now, when the runtime's initialized, we don't actually want to do anything yet. That might be a little bit confusing. We don't want to do anything when the runtime's initialized. We don't care. We want to do something once the user hits the run button, right? So let's go ahead and do it this way. So we'll grab some variables. I think you can do const. I don't know, people have yelled at me in the past. We can grab our input like this, document.getElement by ID, input. There we go. There's our 3 elements. So now we can just start wiring up some events here. So I think, I'm gonna try this off the top of my head. I think this is right. It's add event listener, and the event is click, and then you would put a function here. Although I think the new syntax is like this, right? You guys gotta correct. I know, actually, you guys don't have to correct me if I'm wrong. The console will tell me if there's an error. I'm smart. So when the user clicks, let's go ahead and run the program. Well, we already know how to run the program. We have it here. So let's go ahead and do this. Let's copy this over. We're gonna write the file and we're going to call the file. What are we going to write? We're going to put the contents of something. So let's just put like text. And then we can say const text equals, we want the input dot value. Let's go ahead and add a new line just for safety's sake. I don't think it actually matters, but let's just make sure it ends in a new line. Input dot value, which will grab the input from that. We also have the output element. Are we doing anything with that? We're not, but I do want to do something with the output element. So let's go up here. And then when we print the text, that's why I did this. We want to actually append that to the output. So we can do output dot text content plus equal the text plus a new line. It is new line buffered by default, so we have to add our own new line back. We could also put the error messages there. I could hide them in the console. I would like to hide them because I know there's a lot, but you know what? Let's be good. Let's put them here. So text plus a new line. There we go. I think this is good to go. Let's verify this. We create the module. When we get new input, we just append it to that div that we've created above, or that pre-encode block. Then we source the bash wasm thing, and then we check when the run button is clicked. We grab the input text, we write it to the sudo file system, and we call it with that. This should work. So let's go ahead and test this. We called it text area. Okay, very small. Very, very small, but let's check it. Let's hit run. And nothing happens. Okay, so it broke. But hey, the styling's working. It's not that bad. Let's go ahead and figure out why it failed. Can't create duplicate variable that shadows a global property run. Okay, so at some point, some variable named run was created. And it looks like there's a function already created run. So that's not great. So let's be good here. I've seen this before. Instead of just calling the variable output, let's call it output EL, short for element. So we can just do EL here and EL here. Input can get an EL, run can get an EL for element. That way we're not overwriting some variables that are already there, or at least attempting to overwrite variables that are already there. So this would be input EL. I think that's it. That should be every version of it. Let's go ahead and save that. Let's go back to the web browser. Let's refresh this. And what I want, let's do this. There we go. This will probably be easier for you guys to see. Let's go ahead and run and see. Oh my God, it worked. Look at that. It echoes high right here. That's amazing. We get some warnings, guys, ignore those, okay? But we can see that it exited with 0. That's awesome. Let's run it again. Okay, well, it doesn't work if we run it a second time. We'll get to that. We'll get to that. But I should be able to put anything here, right? For I in 1.5 do, this looks horrendous with just a regular like font, something that's not monospace. I is $I, done, echo, hello, $user. Let's go ahead and hit run. I is 1, I is 2, I is 3, I is 4, I is 5, and hello with a blank thing. So $user is not set. I don't love all these unsupported syscall warnings, but you know what? We could hide the errors. The only downside is it does conflate standard error with these error messages. It's not actually conflating it. Technically, these errors are being emitted from bash to standard error. So these are legitimately showing up in standard error, which might not be the most beautiful thing, but that's just what's happening here. So there's a couple things we can do. We could just go here and we could just not do anything. We could just say, oh, when there's an error message, we do absolutely nothing, right? We could do that. That would hide the messages. We could also put them in the console. I think that's probably the nicer way to do it. We could also look for the word warning in front of it and just hide it. That's ugly. None of these are great, okay? These aren't great solutions, but let's go ahead and just hide the errors for now, just for testing's sake, okay? Let's just hide some errors. So we'll go here, and I got rid of that long script. That's awesome. I don't want to rewrite this from scratch, but I will, because it's fun. 1.10, look at that, we'll go up to 10. Echo I is $I. We don't need that, done. Let's go ahead and save that to my clipboard. Let's hit run. Look at that, that's beautiful. Now it doesn't get rid of the output ... so we could just go ahead and get rid of that. But still, it works. How awesome is that? That's great. If we hit run again, nothing happens. It actually doesn't work, nothing happens at all. We'll get to that. All right, first things first, let's go ahead and get rid of this output ... thing. What we can do is when the user clicks the run button, we can just take the output element el and just say text content equals nothing. So we can just null it out that way. So when they hit run, we'll just completely wipe whatever's there. Also for here, we have echo hi. Let's go ahead and just do this because I'll probably end up writing this a bunch. Let's just change it to this. There we go. So we at least have like some sort of script in there. So if we save this, let's just go double check, make sure that works. If we refresh here, look at this. We already have that. That's super nice. If we hit run, it gets rid of the word output. So that's great. This is awesome. We are running bash scripts in the web browser. So that is huge. The next thing we have to do is deal with the fact that if we change this to like this and we hit rerun, nothing happens. We need this to be able to rerun. We need to modularize this. That's key word here. So back in the documentation here, the linker flags, there is this modularize thing that we're going to need. So by default, we emit all code in a straightforward way to the output.js file. That means that if you load it in the script tag, it all just works. Hey, that's great. But what we need is we need some sort of way where we can recall this or recreate a new bash module. So I'll show you what that means, but basically instead of defining our all caps module, we will use this new function that will generate one for us. And we don't have to use export name. We can specify our own export name, which is super nice. I think it's actually just called export name. Yeah, there you go. So we can just give it our own like factory method name. I'll show you. So let's go over here. Let's pull up the source code and let's rewrite this to be more modular. All right, so we pull in the bash.js. We're going to treat this like it's been modularized. We have to recompile it. I haven't done that yet, but we're going to have to, we'll make sure we do that, or I'll forget and it'll be really funny when we get into an error message. But let's go ahead and modify this so it'll work with a more modular way of doing it. So where we define module here, we'll actually define it inside here. So let's get rid of these script tags that we don't need anymore. And let's go ahead and actually define it. This is gonna be weird. We're gonna define it in here, in the click method. So we're gonna redefine it every time. Now we're not actually gonna do it this way. We're gonna change this to lowercase module, and we're gonna set this equal to await create bash module. I haven't defined this yet, but this is going to be the factory method that's going to exist. It needs an open and close paren because it's a function, and then it takes the exact same argument option, which is super nice. So lowercase module here, we will await it because it is a promise, and we can do all the same stuff here, no initial run, that's super good. And now anytime we call the all caps module, we just have to change that to be the lowercase module, and that's it. So we will create a new module, load the script contents into a file, execute that file, and then we are done. And then the next time the person clicks run, we will do the exact same thing. So that is super cool, but we have to, of course, make some modifications for this to work. There's a couple modifications. So let's go ahead and recompile it. So go back here, go into our build directory. Where we have em make, we have these LD flags. We need to add some more LD flags. So if you remember, modularize equals 1 and export name equals create bash module. So that's the function that we knew that was going to exist. We're actually just going to force that to exist. We have to do a make clean first, and this will recompile it in a more modularized fashion. There is one little change we'll probably have to make. I'm going to see if we're going to hit this error or not. This will be fun to see. Cool. So it's recompiled. Let's go back into our web directory here. Now we have the more modular version of it. And let's just see if it works, okay? Let's go over here and let's refresh this text area one. And we have the output ... Let's go ahead and hit run, and it breaks. It doesn't work. This is good. I expected this, but I'm going to show you why. Create bash module expected semicolon after variable declaration. It doesn't like line 31 of text area.html. Swap this parenthesis and this curly brace because this would cause all sorts of issues. So if you're watching this like, Dave, are you going to notice this? I'll get there. Don't worry, guys. Oh boy. Let's swap those. Let's go back over to the web browser and let's see what's going on here. Refresh the page, run, and we still get an error message. So let's go ahead and pop open that console. Unexpected identifier, create bash module after variable declaration. Okay, there's a couple more things I can try. I think I don't know. There's a couple things that, I hate web development so much. I don't like JavaScript that much. That's why we're making bash work here. But we unfortunately have to get this JavaScript part out of the way. I think I need to make this function async because it does a promise in there, or because it's in a promise. Because it uses await here? I don't know. I think I need to do this. I think that's all I need to do, right? If I refresh this, take your bets in the comments right now if this is gonna work. Oh, that was it. That is what I needed to do. Look at this. Beautiful. It worked. That's amazing. We have it. Now, let's try to make some modifications. If I put AOEU here. It works. we can rerun it. Now, we are throwing out standard error, so if we redirect this to standard error and then echo hi to standard out down here, we should only get hi because we're throwing out standard error because I didn't like those warnings. That's not fantastic, but we could do this. We could run any sort of bash script here. We could treat this like a terminal. I could run ls and then it can yell at me because ls is not installed. We don't have access to those commands. We only have bash built-ins. Dave, what are some commands built into bash? I am so glad you asked. Compgen -b. Here you go. Here's all the commands we have access to. We could do a whole bunch of stuff with this. We could call exit. We could call exit with 0, and then it doesn't do anything. We could check if there is a file named, let's just say if it exists, dev null, then echo dev null exists. Close this, hit run, and dev null exists. Hey, that's pretty cool. That means we should probably be able to cd to dev, right? And that should be successful. So look at that, we were able to successfully cd into dev. We could echo star and enumerate all of the files there. So hey, look at this, let's cd to slash and then enumerate all the files there. So here's what we have in slash. We have dev, home, proc, script, and temp. Of course we have script, that's the name of our program. We have some interesting things here. Can we echo star slash star? This should be everything. Dev null, dev random, dev shm. We have shared memory, that's pretty cool. Home web user and proc self. Interesting. Okay, echo proc self star. So we don't have ls, but this is the closest thing we have. Self fd. Wow, we have a whole fd directory. That's so interesting. I wonder if it does actual enumeration of 0, 1, and 2. Let's see. Oh, we have, wow, 255 and 3. Interesting. Okay, that's really cool. Wow, I actually didn't expect us to have all of this stuff. What is our present working directory? We are there. Okay, so what do we have? cd home echo star web user, cd home web user. Nothing. Okay, so we're just getting a literal star there. Or there's a file named star, but I highly doubt that one. So this is a super dumb way of using bash, but hey, it works. How cool is this? This is pretty sweet. So what is left? What is left to do to actually make a website in bash? Well, there are two things we have to do. One, we need to be able to put the bash source code in the HTML file the same way that we could put JavaScript source code in the file. Because if you're looking at this, right, we just have script and there's JavaScript here. I want to be able to say script type equals text/bash, and I just want to put bash in there and have it be executed. That would be really cool. The second thing is I want to be able to modify the DOM. I want to be able to make changes to the website. I want to change the title of the web browser. I want to be able to modify HTML elements on the page. We're going to need to add our own built-in to bash, our own command. So let's start with the script loader and then we'll worry about adding a new built-in. So let's do that next. So let's cp text area, we'll call it loader.html, and this will be our bash loader. So what I mean by that is, see how we have this code here in a text area? We don't actually want that. We want that code to be in a script tag. Script, but type equals text/bash. So we'll have a script tag here. We'll be able to just put bash code there, and then we'll close it like that. So the syntax highlighting is a little bit gnarly, but we should be able to put bash code like this and have it be executed by something. So let's go ahead and figure out exactly how we do that, okay? So we have our bash script here. So that's great. We load in our bash wasm file here. That's great. Then we have a whole bunch of stuff here. That's great. Let's clean this up a little bit. We'll eventually put this in its own file, but for now, let's go ahead and invent the functions that we'll need. So we need a function for running a script. So run bash script. We can't just use the name run because it yelled at me last time. Run bash script, and this will take the source, the bash source code file. So we'll have a script that can run the bash script. It'll create the module for us. It'll do all that stuff there. And let's figure out what that would actually look like. It's almost like we hit the run button, right? So we can just take this stuff and put it in the run bash script here. So we make a module, create bash module. Let's not do anything with the output. So the outputs will just go to the console no matter what. We're putting nothing in there because we don't want it to actually be able to modify anything. We're just going to put the output in the console the same way that if I were to call console.log in JavaScript, it would go to the console. So we have no initial run here. That's great. Then we actually have to run the program. We have to get the program text. Where's the program text? Well, it's in this script tag with type equals text/bash. So we can get all of those elements and run them. Now, this example, this function only handles one thing at a time. So let's go ahead and do that. So we have the text is equal to the source plus a new line, just to be careful. I think I'm being overly pedantic here. We write that out, we call it, and that's good to go. That's awesome. There's our function right there. Now we need to find all bash scripts in this file. So we need to find all of the tags, all of the script tags that have type equal text slash bash. Now, luckily, because I learned jQuery a million years ago, we can actually just find this using the built-in query selectors that it has. So we can do something like const scripts equals document.query selector all. And now we can actually give it sort of like the CSS selector. I don't know what these things are called, but I know how to write them because I learned them before for a previous video. We want all the script tags that have type equals text slash bash. There we go. So we're gonna find all of the bash scripts on this page and we're gonna loop them. So for const, I have to look off screen for this because I had to actually look up the syntax because I don't know this off the top of my head. When I was writing JavaScript, we didn't have the of keyword. So a lot of things have changed for the better. For the better, let me be honest, for the better things have changed, which is super nice. For const script el, we'll say element. I don't want to overwrite any of these variables. Do we actually have to? I don't know. I've been inconsistent up till now, so who cares? We are going to run bash script with script.text content. So we'll grab the text content of the script tag. This is run bash script, not plural, and this I think needs await. Yeah, we need to await because it's an async function. I think that's it. I think this will work. So let's go over to our website here, loader.html, load it up, and we get a blank page. Now we have to look at the console. Unexpected identifier, run bash script. Okay, line 37 has failed, so let's iterate on that. Go over here, line 37, take a look at it, run bash script. Well, it is there. What am I doing wrong here? Oh my God, I know what this is. This is the thing I ran into before. Oh, I just learned about this recently too because I got yelled at. I think, okay, I actually could be wrong. I could be completely barking up the wrong tree. I think you have to do this. I think because we're at the top level, we're not inside like a function or anything. I think I need, in order to use await, I think I have to do this. I don't know JavaScript very well. Dude, you guys in the comments are gonna have to explain to me why this works. We're gonna find out if this works, actually. I actually have no idea if this is gonna work. If it does, you guys have to explain to me why it works. Okay, so it worked. Again, we're getting a lot of error messages, but that's okay. Just ignore those error messages, all right? IS1, IS2, IS3, IS4, all the way up to that. Okay, yeah, I think you have to do type equals module to be able to wrap it in something so that way you can use the await keyword and something actually waits on it. I don't know, dude. This is a world that I'm outside of. I'm just trying to get Bash to work in the browser. So really, like, I don't know if anyone should listen to my opinions, but it works. Look at this. This is huge. This works. We have Bash code in our HTML and it's being executed by this loader down here. This is a very, very simple loader. So let's go ahead and pull that logic out. CP loader.html to loader.js. Let's call this bash loader.js. So vim bash loader.js. We can go ahead and get rid of all this stuff here. And let's go ahead and bring this down a little bit. And there we go. So this will load all of the JS files that it finds. So that way, if we open up loader.html again, instead of this, we can just say script source equals bash loader.js. Do you also need type equals module here? I don't know the answer to this. You guys might have to help me with this. Script. I think we can just do that. So if we pull in bash.js, which has the wasm, and bash loader.js, it should just execute this. This should just execute. Like, that should just work. So let's go over here, refresh the page, pull up the console, and it works. It absolutely works. How awesome is that? It found all the bash scripts on the page. We should actually verify that. Hold on. Let me verify that and make sure I know what I'm talking about. So what we can do is pull back open loader.html. Let's do a couple things here. Let's make this go up to 3. Let's copy and paste this and open up a brand new script tag. And let's make this go from 6 all the way up to 9. So 1 to 3 and 6 to 9 should show up. So if we go back here, we're going to get a lot of those error messages, which are super ugly. Refresh the page, load this up. 1, 2, 3, 6, 7, 8, 9. Right, yeah, because 6, for some reason I thought 6 and 9 would be 3 numbers, and I forget it's inclusive. So yeah, okay, perfect. This is exactly what we wanted to see. That makes sense. That's awesome. Stupid amount of error messages there. I don't love that, but again, we can just hide them, so who cares? This works. This is huge. This is awesome. We are just running Bash on a website. How cool is that? The last thing we have to do is let's actually make something useful here. Okay, you guys ready for this? Let's have some fun with this. So let's go ahead. Let's pop back open the terminal, and we have one more thing to do. We are going to make a new built-in command, because if you remember before, I ran this on the web. I ran compgen -b, and this listed all of the commands that are built into Bash. We're going to add a new one. We're going to add a new one called web, and it's going to allow us to hook into the JavaScript world. So from Bash, we'll be able to call web, and I'm imagining something like this. Imagine web dom.write a selector like out and some text like hello world. I imagine something like that. Of course, it's not going to work here. Or, you know, document.title my new title, and this will set the title of the web browser. That's what I'm imagining. Let's go ahead and write that. So in order to do that, we got to go into the Bash source code, and in here, there's a directory called built-in. So these are all the commands that are built in. You can see them here, which is super nice. They're C files. They're called .def. You can see that they actually get used to generate a C file. So it's C with some other language around it. We'll mess with that. Let's go ahead and take a look at, let's look at the simplest one, which is colon. Colon's built into your shell, does absolutely nothing, and returns success. So if we look at colon.def, we can see that it's very, very simple. If I scroll to the bottom, it's 74 lines long. I'm going to set the file type to C so we get better syntax highlighting. You can see, okay, we have this file is colon.def, from which is created colon.c. It implements the built-in colon in Bash. We have the copyright header for the GNU GPL v3 up here. And then we have this sort of metadata, produces colon.c, the built-in name, the document name, the function, some short documentation on it, all sorts of fun stuff here. Then we have the actual C code, which does all of this for us. So that's pretty simple, pretty easy. Let's go ahead and look at a more complex one like echo. Echo is still a simple, command, but let's take a look at echo because the implementation is a little bit more involved. The implementation of the echo built in here actually takes a list of all the arguments and loops over them. It's a linked list of arguments, so it loops over them. We're gonna have to do a little bit of that. We'll get to that when we get to that. So for now, what I want to do is we are going to cp echo to web.def. We're going to work off of something that's already had some work done to it. So let's open up web.def, set file type equal to C, and let's go ahead and make some changes. It implements the built-in web. I'm not going to touch the copyright. I'm not worried about any of that stuff. This produces web.c. Okay, very simple. The built-in is web. The function will be web underbar built in. That's the function that's being used here. Depends on, we don't need any of that. We'll call this web ... Go from bash into the web/DOM manipulation. I don't know. I'm not worried about winning awards for documentation here. This is a proof of concept. Let's go ahead and trash all this. Exit status returns success unless a write error occurs. Sure, fine. And this is another built-in one. Okay, this is because there's different versions of Echo depending on if you're targeting like V9 Echo or XPG, whatever that one is. Yeah, so that makes sense. We can get rid of a lot of this stuff, which is super nice. So let's go down here. Echo built-in. Nope. This is our web built-in now. And let's go ahead and trash a bunch of this stuff. We don't need any of this fancy stuff. Let's go ahead and get all the way to the bottom, and let's return execution success. There we go. Nothing fancy going on here. Let's just make a simple built-in that just returns success, so then we can verify that, hey, like this thing actually kind of works. So let's make sure this is enough to make it work. We have to add this file to the make file. This is makefile.in. This will get made during the compilation step, so we'll have to rebuild, we'll have to reconfigure and remake it. Not a huge deal, but let's go ahead and look for some of that stuff. So we had echo.def. You can see that here's a list of all the def source codes. Let's go ahead and add a new one. We want source dir web.def. There's one more place we have to look, which is O file. So here are all the O files. So we have to go ahead and add the object file for web.o. There you go. Cool. So let's save this and let's try and compile it and hope that it works. I think that's all we can do, really. Here into build, we have all sorts of stuff here. Let's do an emake clean. Yeah, was it make clean? There we go. And then we will make it again. And this should compile it, and we'll be able to see that it actually compiled our built-in. If this works, we should have the exact same output, but when we go to run bash code, we will have the new built-in called web. It won't do anything, it'll just exit success, but it will be there. We can start implementing it. All right, it compiled. Let's go ahead and test this. Let's pull back up the web browser, and we don't want to test it on this one. Let's go ahead and pull up text area. There we go, because now I can run something like comp gen -b, list all of the built-ins, and look for web. I don't see web down here. All right, so web is definitely not built in. If I do command-v web, or even if I just run web on its own, we get nothing. We get absolutely nothing. So let's just verify that worked. Echo hi. Did we not update the text area to use the new modularized version of it? We may not have. Hold on. No, we do. What's going on here? Why is it not working? Okay, that's working. I don't know what I did wrong here. Command-v web. Compgen's a shell built in. Oh, it just prints nothing if nothing's there. Okay, so if I do type-a type-a web type-a type, it just prints nothing for web. Yeah, that makes sense. Okay, yeah. Right, and we're discarding errors. Of course, yeah, the thing is probably printing errors. I mean, I'm just discarding them. Yeah, see, this is why you don't discard errors, guys. Do as I say or not as I do. I don't know. Don't compile bash for the web browser at all. All right, so it didn't compile that. I may have missed it somewhere in a file. I'm not entirely sure, but I don't think so. So let's go ahead and just do the thing we did last time, which was delete everything in the build directory, and we'll run the configure, and then we'll run the make again. Let's just start from a clean slate and make sure everything's working how I expect it to work, just so we can kind of rule out any weirdness there. Can I just ls built-ins? Because there's a whole bunch of stuff here. Oh, we have a web.o in there, right? Yeah, web.o is there, so maybe it worked? I don't know. Let's go back over here. Let's refresh this. Actually, let's copy this to my clipboard first. Hey, I'm learning. Refresh. Go up here. Paste that into the clipboard. Run. We have web. We have web now. It works. So we echo hi, web, echo bye. We get nothing, which is good. We don't expect it to do anything. Let's go ahead and stop throwing out the errors, because I think it might be beneficial to see the errors. I should probably add a checkbox to make it so, you know, we don't hide the errors all the time, or be able to toggle them on and off would probably be nice. But yeah, let's go ahead and do that, because I think it'll just be useful. Turn the errors back on. There we go. So, okay, we get a bunch of stuff. We get hi and we get bye. So if I ran like, you know, type foo, doesn't show up. Nice, we're actually getting error messages. Oh, you could probably just throw out warning : error messages, but who cares? This is fine. Web is a shell built in. Awesome. We have made a shell built in. It doesn't talk to JavaScript at all. It doesn't do anything yet, but we have a new shell built in. That is huge. So let's go back to our source directory here. Oh, I got out of that directory. Nice, good job, me. We are in here, so let's go ahead and implement this a little bit. All right, so list has our arguments here. So the first thing we can do, oh, I'm using tabs and they're using 2 spaces, interesting. We can check if lists equal null, meaning we haven't gotten any arguments. We can emit a usage message and we can break. Now here's the cool thing, a lot of these things are built in. So like if I were to look at all the built-ins here, there's something like, I think it's usage or built-in usage. Yeah, there's a built-in usage function. There's a variable they return also called ex usage. So this is really cool because I don't have to rewrite that, which is nice. So I can say built-in usage and then return ex usage. There you go. So if they don't give me any arguments, I handle it that way. Otherwise, we're good to go. Set file type equals C. So we need to do things. We need to loop the elements, loop the arguments, put them into an array, and then we need to call into JavaScript with the arguments, and then free any arguments that have been allocated. So that's basically what we have to do. Now we have to figure out how to actually go about and do this stuff. So here's the thing about Emscripten, which I really, really like. Emscripten has this beautiful thing built in. I'll show you. So to bridge the gap between C and JavaScript, we have this. So take a look. There's this emjs function where this is C. This is C code. C is calling a function called callAlert, but that function is defined here using emjs. It returns void. It takes nothing as arguments, and this is the body of the function. Look at this body. That is JavaScript. So this is how you bridge between C and JavaScript. So we're going to write JavaScript and it's going to be in the C source file, all to get Bash to work. So in C, we're writing JavaScript to get Bash to work. Yes, it's really dumb, I know, but we're going to do it that way. So I'll show you what that looks like. First thing we do here, include Emscripten.h. We need access to this stuff. Now we need to do em_js. What we're returning, which is a return code, because remember Bash returns numbers, we're going to return an int, a 0 through 255 return code effectively. This is the function that we are going to name it. This is the name of our function, so we'll call this bash_web. That's the name of the function we're defining here. The arguments we're going to take is we're going to take like a normal C program. We're going to take an int of argc and a char ** of argv. This will be an array of arguments. This will be all the arguments that were given to the web built in. We're going to pass them directly to JavaScript. Open up the function body here, close the function body here. It doesn't like this syntax, my syntax highlighter. That's totally fine. It's still valid. And in here, JavaScript goes. So what we'll do here is we'll say const args equals a new array. For let I equal 0, I less than argz, I plus plus. We're going to loop over the argc and we're going to load the argv into the array. So args.push argv at spot I. Now here's the thing. We have to use this function because we're going from C to JavaScript. We have to use this function that we have access to, UTF-8 to string. This will handle pulling it out of the heap and putting it into our JavaScript. There may still be something else we have to do, subtle foreshadowing, but for now we're going to do this. And now we're going to return. Remember, we are in JavaScript, so we have global this. We will return whatever the output of this function is, bash web internal, given the arguments. So if you're not familiar, global this is relatively new in JavaScript. Instead of having to like figure out if it's a global or window or whatever the global context is, you should just have this variable. We're going to look for a globally defined function called bash web internal. This doesn't exist yet. I haven't created it yet, but this is how we're going to jump from the C code into the JavaScript land. So this will work once we go and actually create that. So now we need to give this function bash web the argc and the argv. So how do we go about doing that? Well, we got to extract it out of this linked list of arguments that bash gives us. I don't know if they've been allocated on the heap or the stack. I think they're probably on the heap. To be safe, we're going to reallocate them on the heap. We're going to allocate new space for them, bring them into JavaScript land, and then free them ourselves. It might be excessive work, but we're going to do it because this way we're safe. So what we need to do first is count the number of arguments we have. So argc will start at 0. Now we have to loop over all the arguments. So in order to do that, we need a word list of node. If you've ever looped over linked lists, this is going to look really familiar to you. If you never have, you're going to be very confused. So node equals list, node not equal null, node equals node next. This is very confusing. I don't have time to break into exactly what's happening here, but we have a node object. While it's not empty, we're going to move to the next one in the linked list. I guess I did have time to explain it. So there you go. That's all we're doing. And we're going to do argc++. We are counting the nodes in a linked list. That's all we're doing here. We're not reversing it. We're not interviewing for some job that makes you do that. Nope, we're just counting the items in a linked list. That way we can allocate based on that. Now here's the beautiful thing. We don't have to call malloc ourselves. We can call xmalloc because these bash built-ins have a bunch of things for us to use, which are super cool. So we have this xmalloc function, which is available to us, which is, where is it defined? There we go. So Bash has these built-in helpers for us. Xmalloc is one of them, which will actually malloc, allocate memory. And if it fails, it'll already handle an error message for us. So it's a safe wrapper around that. There are some other ones. Instead of stirdup, they have save string. Save string, again, is like a safe version of stirdup because it stir copies but uses xmalloc. So again, it's a way of duplicating a string in Bash or in the C code that is Bash without having to check errors manually because the errors are checked for you. So we're going to leverage those like you would not believe. File type equals C. So now that we're here, we can do something really simple. We can just say char ** argv, we're making our own, equals xmalloc argc, the number of items we have, times the size of the arguments or the size of the objects we're holding, which is a char *, a pointer to character data, a string. We're holding the first character of a string. So we've allocated argv with enough room, exactly enough room. We don't have a trailing null at the end of it. We just have exactly enough room for all of the arguments that we have. Now that we have this and we verified it worked, we can loop over the list again. So let's loop over the linked list. We already have that. I'm going to copy it down here. Loop the arguments, put them into the array. Oh, I'm putting them in the wrong spot. There we go. move this here. Now we're going to loop over them, and we're going to push the string onto argv. Now we don't have a push method, so we have to keep track of what element we're on. So we can just do a very simple I equals 0 here, and then we'll just do argv I plus plus here. So I will get incremented, but it will start at 0 and work its way up, which is super nice. Now we can set it equal to node word word. Yes, confusing, but this is from the bash built-ins. This is the actual argument itself, and we need to duplicate it. So let's just use save string on it. Again, built-in, Bash has this by default in its own little helper utility function, so super useful. Now, finally, let's call into JavaScript with the arguments. Let's actually call our function bash web with argc and argv. If you remember, it returns an int, so let's say int status equals this. We now have the status code, so we can return the status down here. The last thing we have to do, the final thing, is we just have to free the elements that we had. So let's go ahead and do a for I equals 0, I less than argc, I plus plus, free argv at I, and now that we freed the string that was stored in there, we have to free the entire thing itself, so free argv itself. There we go. This should work. There was a lot going on here. Hopefully it all made sense. This allows us to call into bash web, which is an emjs function, which calls into this. So this bash web internal function will exist in JavaScript land, and we will be able to call that. So let's save that. Let's go out here, let's go into our build directory, and let's make sure we can actually build it and it works, because there's a good chance I probably put a syntax error in there somewhere, right? I'm not above that, I'm human. So let's make this and hope that the web built-in makes successfully. Okay, we have a syntax error. This one's super obvious. It's because I'm jumping between C and JavaScript. So JavaScript has all lowercase null. C does not have that. C has all uppercase null. So yeah, that's just a really simple error that can happen when you're going back and forth between languages. So search for null. This should be null. I think I do it again here, and that's it. So that looks fine. I think we can just recompile without having to do a make clean. Hopefully it'll just redo that. I think it should be fine. Hopefully, because I don't want to sit here and wait for this all night. There we go. Let's go test this now, because if this works, we should have our built-in and we should be able to run it, and it should try to run some JavaScript code. That code doesn't exist. It's going to fail. But let's make some progress here. So if we go to the bash wasm test here, refresh the page, go here, we should be able to call web on its own, and it should do something. We should get an error. Usage web. Oh, we got the usage message. Okay, that's good. We got the usage message. We didn't give it any argument. So let's go ahead and give it foo bar baz. Copy that to my clipboard. Run. Assertion failure. UTF-8 to string expects a number. Got undefined. So we have an error here. I hinted at this error earlier. I'm going to show you how to fix it. It's a really dumb error, and I'll show you how I actually found the fix for this, because it's really, really silly, actually. I was looking up this error, and I found this closed issue on Emscripten, EMJS, and you can see that someone gave a solution down here, and this solution is what we're going to use right here. So where we do array.push UTF-8 to string, they're doing heap 32, and they're doing argv shifted 2. And it's because of the way the strings are actually stored. We're getting pointers that don't really make sense. We have to pull them off of the raw heap. It's weird. I don't love that the syntax is like it. I'll be honest, I don't even fully understand it. But at this point, I just want to get this thing working. So set ft equals c. You can see that we call it here, args.push UTF-8 string here. What they do is they just do heap. I'm just going to copy it exactly. You can't see it. Heap 32 of heap 32 is an array, and inside that array is argv shifted 2 plus I. So that is what they're doing here, and that seems to fix the issue. So let's go ahead and do that. I think we can rebuild it. Nope, it won't work. So now that we have that, let's go ahead and make clean it and rebuild it, and hopefully I copied everything over right, and hopefully this just works. It's not really an issue. It probably makes sense if I were to spend more time actually really wrapping my head around this, but this works, so we're going to use it. There we go. It compiled. Let's go pull up that website again. Refresh here, and then we'll do web foo bar baz, hit run, and we get nothing. That's kind of huge. We get nothing. We get no error. Nothing actually ran, but let's go look at the console. Look at this. Unhandled promise rejection. Global this bash web not internal is not a function. That's good. That's a good thing. That just means if we define that function, we should be good. We should be in a good place. So let's go define that function. This is just JavaScript stuff going forward now. You think that'd be happier about that, but actually I'm just not good at it. So let's see if we can get this to work. So let's go back into our web directory. And I'm going to go ahead and put this in the bash loader. I feel like it makes sense to put in the loader. Yes, this is the loader, but also define the web built-in helper function. So now we can do global this, and as long as we do it correctly, global this dot bash web internal equals, it's a function. I think functions are just like this now. That takes argv, that's all it takes, like this. That's it. Is that valid syntax? No, you need this, right? Hopefully it's valid syntax. So we have a function here, and that takes argv, so we can do a console.log of argv. Okay. I think that makes sense. We don't even need to recompile anything because it's just in a JavaScript file. So let's go here. Let's refresh this. Web foo bar baz. Pull up the console. It still breaks, but I think I know why. I think it's actually, is it just this? Is it because I defined this below and it needs to be above? Is that all it is? If I just defined it as a function, would have got hoisted to the top? I don't actually know. Let's go ahead and save that. Let's double check this before I make this any more complicated than it needs to be. Refresh, paste, run, look it up here. Bash web internal is not a function. Okay. Oh no, is it because I made it a module again? Is that the problem? Is the problem because I made it a module that I won't be able to access global this? That doesn't seem right, does it? What if I do this? Hope you guys don't mind the live debugging on the fly, because I really just don't understand JavaScript. Oh, I've been at this for too long. It's because bash loader is not being included in text area.html. That's all it is. That's all it is. I know it is. Let's go back here. Let's just include it, right? We have bash.js. We have bash loader. I think this will work then. I think that might be what I'm missing here, that I just wasn't pulling it in. Hey, let's not forget this. Let's not forget that, guys. I promise I'm really good at computers. Refresh. Go here. Web foo. Do this. Hey, that looks different. Go here. We have foo as the arguments. Look at that. Foo in an array of arguments. Foo bar baz hello Dave as a string, foo bar baz hello Dave as a string. Look at that. Oh, we're getting there. We're getting there. Look at that. We are calling it a JavaScript. Let's make this useful now. Okay. Open up the bash loader. And there we go. We have this. This is our insight into what's going on. This is our bridge from C all the way back into JavaScript. So bash can do this. So what's left to do here? We need to implement some things that we want. Let's grab the arguments out of it, because we can grab the first one. I like this syntax that JavaScript has. Is it splatting? I don't actually know, but I can do this equals argv. So now command is the first argument that was given to us, which has to be there. And then args or whatever arguments go to that command. I'll show you why that's cool right now. We can do a switch statement over command. And this will be the first argument given to the web built-in. So we could have things, I think I mentioned, like dom.write. Cool. So there's our first command, and we can just have it do nothing. We can make our second command. What did I say? Like document.title, something like that. And this will be our second command, which will set the title of the web browser. Just an example. And then we can do a default case where we could say like console.error unknown command, and then we can return 1, because remember, we're returning code that bash understands. So instead of break here, let's just return 0. Instead of break here, let's just return 0. So now we can do a dom.write and a document.title. When we're here, we could do something like console.log dom.write, and then %s, we can just do the args that we were given here. So we can do some sort of like debugging on the fly. So let's make a new HTML file, okay? We have the loader.html. Let's make final.html. So this will be our website, bash website. This is what I promised that we would do, and this is what we're gonna do. We have our bash script here, and we will do something like, let's make a div ID equals output, close it here, and we can do dom.write. Let's do a web dom.write of output hello world, and a web document.title of my new title. There we go. If this all works, because this is valid bash, we could also say like, hi, this is just bash lol, and we could wrap this in an if true if we wanted to. I don't know why I'd want to do it, but just to prove that it is bash, we could do this. So we haven't implemented anything yet, but this is what the final website will look like. So if I go over here and I pull up the website, here we go. We got nothing, but let's pull up the console. Hi, this is just bash. Dom.write is an array. Okay, so we have our internal functions are doing something. Let's go ahead and make them do something useful now. So here we go. All we have to do is implement these two things and we have a little website maker. Of course, there's a ton more to implement. For the sake of this video, this is a proof of concept. We're just gonna implement what we need here. So let's go ahead and do that. For our dom.write, we need to grab the selector and the text. So the const selector will be args at spot 0. The const text will be args at spot 1. There we go. So now we can just say const L for element will equal document.query selector, and then we can check if not L, then return 1 because we failed to find the element. Otherwise, if we have it, then we can just say L.text content equals text. There you go. And then for document.title, this one's even easier. Const text equals args at spot 0. Document.title equals text. There we go. That should be it. What do you think is going to happen when we go to this website now? Let's pull it up here. Let's refresh the page. And we get an error. Cannot declare a const variable twice, line 19. So close. Line 19. Look at this. See how we have const text here, but we also have const text here? Does JavaScript allow this? Can you just put curly braces here? Here's how I'd solve it in C. Does JavaScript let you do that? Sometimes JavaScript's a lot like C. I don't know if this will work or not. I think it will. Ideally, these would probably be in separate functions or whatever, but for now, let's just do this. Let's go back to the website and let's see. Moment of truth. Hello world. Look at this. I'm pointing at my screen. My new title. Look at that. We did it. Website in Bash. Now, obviously, this isn't the prettiest website. It's not the most feature-complete website, but this is a website that was rendered using Bash, actually compiled for WASM. Look, my new title, Hello World. The source code is, that's not it. The source code is here. This is the entire HTML file. Look at this. Script type equals text bash. It works. It works. Dude, if you made it this far, you are a legend. This was supposed to be an April Fool's Day joke. I thought, hey, wouldn't it be funny to compile Bash for the web browser? And you know what? I was right. It is hilarious. And I can't believe it actually works. I did not expect it to take this long. This was supposed to be a lighthearted small video. This ended up taking longer than some of my like educational content. Okay, there was so much I had to figure out to get this working, but it works. How huge is this? This is awesome. So now all that's really left, I'm not going to do anything left here. I'm done with this. But all that would be left if you wanted to take over this project, you just have to add more things here. So yeah, there we go. That's a website in Bash. We compiled it. There you go. It works. Like, what else do I say? That's crazy. So if I go to the text area here, I think I can still use the web built in, right? There we go. Look at this. Web document title foo. It changed to foo up here. If I change it to my PID is $, and I run it, my PID is 42. Look at that. Emscripten automatically puts 42 as the PID. So it works. It absolutely works. This is ridiculous, but it just works. Technically, okay, hold on. I could do dom.write. Hear me out. Let's grab every button. And could I change it to haha? Will it just change the button text to haha? It does. Every single button on the page just had its text changed to haha. That's so ridiculous. Technically, I could change text area to like echo hi, and then it will overwrite its own code. No, because it's text content, not value. Okay, so that one won't work. But I could do like, oh my God, could I just change this to body? And I could just change this to LOL, and then it just overwrites the entire page. This is crazy. This is crazy. So yeah, there you go. Hopefully you enjoyed this April Fool's Day joke. It's not even really a joke. I actually did it. I actually compiled Bash for wasm. I can't believe I did this. I will clean up this code. I will make it available on GitHub. I will have the links below. I actually have to go ahead and do that now. That's going to suck. I will also upload these HTML files. Maybe I'll clean them up a little bit, but I will upload them to my web server so you'll be able to pull them. I haven't done it yet, so I will link them below when it's all done. But yeah, dude, if you made it this far, you're awesome. Go ahead and hit the subscribe button. I appreciate it so much. Hopefully you guys enjoyed this. This was a weird video, but I had a ton of fun making it. What a ridiculous idea for a video. Thank you so much for watching. You guys are awesome. I appreciate it. Yo, shout out to all my members over at Patreon, my patrons over at Patreon. Thank you for your continued support. You guys are awesome. You get your name at the end of my video. How cool is that? Thank you so much, dude. I appreciate it. You guys are awesome. Hopefully you enjoyed this video. What a ridiculous video it was. I don't even know what else to say there. That's all I got. See you, everyone. Take care. All right, it's still installing, but this will be a little bonus for you guys. If you watch one of my previous videos where I talked about Bad Cop's website where she has hotdogstand.lol, and if you curl it, it does this to your terminal. Horrendous, where it changes the whole theme. Well, I created my own. You can curl ysap.sh/theme, and look at this. It will revert it. Now, it won't technically revert it. What it does is it actually applies my custom theme. It even prints my logo. How nice is that? So it does a whole bunch of stuff, but it basically does my whole custom theme. So there's a lot of stuff going on here. These are the codes you actually care about where it applies my theme. I have that in my Bash RC somewhere. I don't have it loaded here. But yeah, so if you want to undo the hot dog stand, you can run that. But I'll probably put this at the end of the video.